So we already have learned about the formula of the quadratic equation, and so if you have a quadratic equation ax square plus bx plus c equals to 0, then we say that the value of x is minus b plus minus root over b square minus 4ac by 2a. And you know the quadratic equation will have always two roots. I mean to say there will be two values which will be satisfying these equations. Okay, so these two roots are minus b plus root over b square minus 4ac by 2a, and another one minus b minus root over b square minus 4ac by 2a. Okay, now let's talk about the nature of root. So what will be the nature of root, right? Nature of roots, correct? See, as a, b, c all are real values, a, b, c are real values, okay? So there is no problem with this, no problem with minus b, no problem with minus b, no problem with 2a. There is a situation when this value will not come if a is equal to 0, but a can't be 0 because it's a quadratic equation. So no problem with 2a also. But there is some problem with b square minus 4ac. Let's talk about the problems. The three scenario I'm going to talk about b square minus 4ac. So because all the scenario depends on b square minus 4ac, so we call it discriminant, okay? Discriminant, denoted by capital D, and this is b square minus 4ac, correct? That's why many people write down the same formula, like this: minus b plus minus root over d by 2a, where value of d is b square minus 4ac. Value of d is b square minus 4ac. Okay. Let's see how it is dependent on d. So scenario number 1, case 1, you think if capital D is greater than 0, what does it mean? It means D is positive. So what will happen if D is positive? See, if D is positive, then what will happen is we will get some positive value here, okay? And root over a positive value will be some number. It may be rational, it may be irrational, but it will be some number, right? So we will get all the real values, so the zeros will be real. Okay, you think suppose value of d is positive, okay, so here some value comes up which will be added to b and subtracted to b, so we'll get two values, two different values actually, you can say. So the roots are real and unique. What do you mean by unique? It means I'll be getting two values. This means you can say not same or unequal. So values are real and unequal or unique or not same. Okay. Why unique mean to say both the values are unique in their places, they are not equal, correct? You can take down some example. Like I said, x square minus 3x plus 4 minus 4 equals to 0, correct? So here a equals to 1, b equals to minus 3 and c equals to minus 4. So value of d will be b square minus 4ac. So it will be minus 3 whole square minus 4 into 1 into minus 4. Okay, so it will be 9, negative, negative, positive, 16. So it is 25, correct? So 25 is what? Greater than 0. That's why roots are real and unique. Why? Because d is greater than 0, or we can say positive. Okay, so the roots are real and unique. Now the other scenario, you can take it down like case 2. is D is equals to 0, what will happen? You think suppose D is 0, that this whole value will become 0. So there is no problem with the real values.
Connect iPhone to charging.
So there is no So if D is 0, there is no problem with this one, because if D is 0, then minus B plus minus 0 by 2A. So the result will be minus B plus minus 0 by 2A. If we'll be adding 0 or subtracting 0, the result will be same, so it is minus B by 2A. Am I right? This means the roots are real because B and A are real values, but roots are not different. I'll be getting only one value. So you can say real and equal. And this is a most common case of your examination question. They will ask you, if this is the situation, what will be the value of some other variable, right? So real and equal. So in case of real and equal, the D will be 0. Okay. You can take down some example, like I'm saying x square minus 14x plus 49 equals to 0. See, this is the scenario where we have shown the graph at something like this. It is touching and going like this. That's why the roots are same. Okay. See, this can be here a equals to 1, b equals to minus 14 and c equals to 49. So what is the value of D? D will be b square minus 4ac. So it will be minus 14 square minus 4 into 1 into 49. So the result is 196 minus 49 into 9 is also 196. So result is 0. So as the D is 0, okay, as the D is equal to 0, this means roots are real, but they are equal, or you can say they are same. They are not unique. They are not unique. Okay. Now the third case. This is the in the third case, you can think D can be lesser than 0. What does it mean? It means D is negative. Okay. In this case, what will happen? Let's see. If D is negative, so you know root over negative value, like root over minus 16 is not a real value, right? So when D is less than 0, then the roots are not real anymore. It will be not real, it will be imaginary. Getting it? Okay. In your book, maybe it is written only not real, okay, but better you write down not real but unique. Okay, I mean to say, you can say instead of not real, you can write down here it is imaginary. Or you can say virtual. Let's take an example. Suppose I'm writing x square plus x plus 2 equals to 0. Here a equals to 1, b equals to 1, c equals to 2. So d equals to b square minus 4ac. So it will be 1 square minus 4 into 1 into 2. So it will be 1 minus 8. So it will be minus 7. Which is lesser than 0. I mean to say negative or lesser than 0. This means the roots are not real. But actually they are unique. There will be a complex number, but unique complex number, two different complex number. Okay, clear to you? Now, one extra thing I want to tell you. In this scenario, when D is greater than 0, I can take down one another thing, right? We can come here with one another When d is greater than 0, there is one another situation may comes up. Like number one, when d is greater than 0, I mean to say d is positive, we know the roots are real and unique, correct? But d greater than 0 can be happen in two ways. Okay, one is called, it's a perfect square. It's a perfect square, okay? And another one, it is not a perfect square. You know what is perfect square? Like 4, like 25, like 49, like 144, like 1024, these all are perfect square. Not perfect square, like 10, like 20, like 17, like 24, like 40, like 50, these are not perfect square. So if it is a perfect square, you think if it is a perfect square, then root d will give you an integer, right? Root d will give you an integer value, correct? But if it is not a perfect square, then root d will be a irrational number. Root d will be irrational. Okay? That's why if d is greater than 0, then we have to check either d is a perfect square or not. If it is a perfect square, then the roots are real and rational. But if d is not a perfect square, then we can say that roots are real but they are irrational. Okay, so this is all about the nature of the root. Although I have given one example for each, okay, I haven't given any example for this one, which I will give you right now. Okay, so you can note it down.